Hello all, welcome to this session on facility design. As we said, we will build the concepts of Industry 4.0 on important decision making processes. So one of the important decisions to be made at the very beginning is to decide where the factory is going to be located, and once the location of the factory is decided, we are going to then decide what should be the layout of our facility. So we will take this problem the other way. So in this session, we will discuss about facility layout. Now, what do I mean by facility layout? Facility layout is essentially arrangement of assets in our facility. So we can be thinking about manufacturing facility, and therefore we will say this is my machine number 1, and then this is my machine number 2, and this is my machine number 3. If my machine number 1 is, let us say, lathe, I hope some of you at least understand what a lathe machine is. Some of you understand what a milling machine is. Some of you understand what a drilling machine is. So where am I going to locate all these machines in the facility? So let us say that I have this shop floor, manufacturing shop floor. It could be office floor. So the concepts that we are going to discuss are not only applicable to the manufacturing industry, they can also be applied to service industry, and we will take appropriate examples about that also. So I may locate machine 1 here, machine 2 here, machine 3 here, machine 4 here, or am I going to arrange it in a particular sequence and say that it's actually going to be machine 1, machine 2, machine 3, machine 4, and so on. So what is the layout, right? Now many of you are studying in schools and colleges. Let us look at a college example, right? How are the colleges laid out? So every college has a campus, and what happens in a college campus? So let me create some space by erasing a few things here. So let me erase these things, and let me erase this also. There is nothing particular here. So what happens in a college? Let us say this is my college campus, and typically in a college campus there is going to be this department of computer science, and then there is going to be department of mechanical engineering, and then there is the department of electrical engineering, department of civil engineering. This is my admin office, right? So here the layout is decided based on the department. So that's also an example of layout. That's the purpose of this session. The purpose of this session is to discuss various types of layout, understand the differences. Today, most of the times, the decisions about which type of layout is going to be used is mainly non-mathematical. Mathematics comes in, or data comes in, when we are trying to optimize that layout. So we will talk about some very basic work allocation problem, which is to optimize one particular type of layout. So this is our attempt to explain data-driven decision making. So the decision is fairly clear. We are going to decide how to lay out facilities, right? How to lay out facilities. So that's my problem. We will understand various types of layout, and then we will optimize one of them, which is called a product layout. So why do we need facility layout? We need facility layout. So first of all, the textbook definition of facility layout. Facility layout refers to specific arrangements of physical facilities. As I said, departments are physical facilities. So let us say that you are a fourth year electrical engineering student in a particular college, or in a particular institute, in a particular university. There are going to be some elective courses that you can credit. There are going to be some core courses in electrical engineering department. So in a particular day, what will happen is you will be mostly here in your department trying to credit some courses. Occasionally you will go to a computer science department because you have an elective which is happening there. Maybe there is a Industry 4.0 course offered by mechanical engineering department, so you are probably going to go attend there. Maybe you have some work in the admin office, probably fee related thing, or probably your bona fide certificate, so you will visit there. So essentially you become the work piece, right? That's the terminology that we are going to use. Work piece is the part that is getting processed. So you are sitting in a class, you are acquiring the skills in electrical engineering. So you are getting processed. You go to computer science department, there is some elective, you are getting processed for those 50 minutes. So essentially in this example, the student attending classes, student traveling between the departments is essentially what is called as a work piece. In the manufacturing setup, when these are actually machines, right? Here there is a lathe and there is a milling machine, and then there is a drilling machine. The work piece travels from lathe to milling machine to drilling machine, and then go somewhere else, right? The work piece travels. First it gets processed on the lathe machine, then it gets processed on the milling machine, then it gets processed on the drilling machine, and so on, right? So the idea is still the same, the terminology is still the same, the context becomes different. So facility layout refers to the specific arrangement of physical facilities. Why do we need facility layout? Facility layout is needed when we are setting up a new facility, right? A new facility is getting constructed, or there is a change, there is a significant change in demand or throughput volume. I have not defined what a throughput is. We'll talk about it a little later. So when there is a significant change in demand, probably if I was using one particular type of layout, now because of change in demand, either demand going up or demand going down, I may want to change it to some different layout. Or there is a change in the process, right? Or some new product is being introduced, or there is a change in the process, right? Either I'm changing the technology, I'm introducing a new process, I'm introducing a new equipment, and therefore the layout has to be looked at again and decided whether this is the optimal layout or not, right? So all these reasons will make the facility layout a necessary problem to solve. Okay, so what is the purpose? The purpose of facility layout is to minimize the delay, right? Going back to the university example, right? Now let us say that university knows that there is a lot of collaboration between electrical engineering department and computer science department, or let us say there is a lot of collaboration between computer science department and civil engineering department. It just makes better sense for these two buildings to be located next to each other or close to each other, right? Otherwise, unnecessary travel of students, of faculty members, probably of equipments between the two departments, right? The first purpose of facility layout is to minimize the delays because of material handling and customer movement, right? People movement or material movement or equipment movement. We want to minimize those, right? Maintain flexibility. We want to keep ourselves flexible so that any new type of load comes in, any new type of program has to be offered. Now let us say there is an interdisciplinary course which cuts across mechanical engineering department, electrical engineering department and civil engineering department. What if I want to introduce new course? I have to be flexible enough, and so that my students can still attend classes in these three departments without too much of travel between or amongst them. I have to make sure that I use the labors effectively, or I have to use the space effectively. Those are my resources. Labor is a resource, space is a resource. By space I mean the land that I have, the land availability or the space availability, not the space up there. Promote customer satisfaction. Sometimes in a service facility, this bullet point is particularly true for a service facility. Now you walk into a restaurant, and if the restaurant's layout is horrible, you notice it, right? You are saying, you have often heard yourself say, oh, why are they not arranging the table this way? Why are they not having the service station this way? Why is the cashier's counter somewhere, right? All those things matter to us, and therefore facility layout also has an impact on customer satisfaction. It provides good housekeeping. It provides good maintenance. If the facilities are laid out in a particular way, it facilitates better maintenance, definitely, and it sometimes enhances sales, right? I mean, once again, I can refer you to service facilities. I have visited retail shops where the retail shop had messed up horribly in the layout. And it was very difficult to find items walking into various aisles and so on, right? And therefore it may have an impact on your sales. So layout does matter. right? Facility layout does matter, whether you are talking about manufacturing industry, whether you are talking about retail industry, any industry. We explained in an academic institute, facility layout matters. I hope that point is evident now. All right. So let us understand various types of layout, and the first one among them is product layout. Let me briefly list out the layouts that we are going to discuss. We are going to discuss product layout. We are going to discuss process layout. We are going to discuss group technology layout, GT, group technology layout. We are going to discuss fixed product layout. Okay, so let us understand what each one of them means. First one of them is product layout. What is a product layout? Product layout, it's a very simple thing. What is a good everyday example of product layout? A good everyday example of product layout, I have two examples. Both of them are from service industry, because you don't visit manufacturing facilities every day. I wanted to give you everyday examples. So a good everyday example of a product layout is probably your student mess. Have you been to your student mess? Are you at least some of you staying in the hostels? Probably yes. So when you go to a mess, right? When you go to your dining area, let's not call it a mess. It's probably the cleaner place, so it's not a mess. So when you go to your dining hall or your dining area, what do you see there? Right? What do you see? So you enter, and then there is a big counter, right? There is a big counter, and what happens? You pick up your plates, you pick up your spoons and your smaller containers, the katoris, and then there are all these dishes kept, right? All these dishes are kept, and they are kept in a particular order, right? They are kept in a particular order. So probably you will have vegetables, and then you will have dal, and then you will have rice, and then you will have chapati, and then towards the end they will also keep some curd or desserts, which they know you eat only at the end of your meal, right? So it's arranged in a particular sequence. It is arranged in a particular sequence. It is expected that we all eat in that particular order. Right. So typically, if you see the salads and the appetizers are kept at the beginning here, right here. Notice all the food tables that. Why do even I have to give you the example of your dining hall in your hostels? A wedding reception that you attend, right? A wedding reception that you attend. This is going to be the layout. This is your typical product layout. So what is the product layout? Let me superimpose my bullet point on top of this. So arrangement based on the sequence of operation that are performed, right? I mean, I have written everything in the context of manufacturing, because as I had said earlier in my previous session, Industry 4.0 is mainly started with manufacturing industry in the focus. But like many things, right? Many things, a lot of things have started in the manufacturing industry, and then they have spread out and percolated in other industries, and now they have become commonplace in other industries, right? So TQM, for example, total quality management. If you have heard the term total quality management, now total quality management was a concept that started with manufacturing industry, and then it went and now it has become commonplace, right? Without quality, why are we even worried about anything else, right? One of those. So even though the definition is written in the context of manufacturing, I have given you an example which is clearly not manufacturing. So what is product layout? Product layout is arrangement based on a sequence of operations. As I said, what is the sequence in which you eat? You eat the appetizers first, and then the main course, and then your desserts, and so on. So any food table will arrange these dishes in that particular order. Okay. So it is generally used for mass production. It is generally used for continuous flow, right? Flow shops, right? Those are the typical arrangement that are that have this product layout, right? That have this product layout. Examples are another example is Subway sandwich shops. If you have ever been to a Subway sandwich shop, notice the layout. Your credit card processing. Credit card processing is in a particular sequence. First you do this, then you do this, then you do this, then you do this, right? And the obvious, most famous example of product layout are the automobile assembly lines. Automobile assembly lines. That is how this whole product layout started. So I have kept my promise that I will keep my discussion very generic, not only limited to manufacturing industry. So credit card processing and Subway sandwich shops are non-manufacturing examples of product layout. Your food arrangement is an example of non-manufacturing product layout, and assembly line for manufacturing cars or manufacturing automobiles is the manufacturing example of product layout. I hope this is clear. So this is a pictorial representation of product layout. So the raw material is picked up from the store. So this is a typical manufacturing setup. So it starts with a store, and then the saw is used, then the lathe is used, then the milling machine is used, then the drilling machine is used, and then the product is assembled and product is kept in the warehouse, right? So this is assembly line 1. This is line 1, right? So all the products which are flowing through this line will follow only that sequence. Products that are flowing in this line cannot say that I will have lathe first and then sewing machine, or they cannot say that drilling machine will use before milling machine. Cannot happen. The machines are arranged in the particular order in which the processes take place. However, I may have a different assembly line in the same factory. One factory need not always have a single assembly line. It may have multiple assembly lines. So this particular assembly line, product gets welded first, and then it is ground, then it is turned, and then it is drilled, right? So turning operation happens on a lathe. So one particular factory may have multiple assembly lines. I have shown an example of 4 assembly lines. But once the assembly line is chosen, the sequence of operation is fixed, right? So here the sewing machine is used, and then the milling machine, then the drilling machine, then the painting, right? Paint job. So and then the assembly, and then the warehouse. So the sequence is fixed. Once you fix the assembly line, the sequence is fixed. I hope this is clearer now. I hope now you understand what a product layout is. So what are the advantages of product layout? Very simple, right? To me, product layout is very simple. Arrange the facilities in the exact sequence of operations, right? So since the layout corresponds to sequence of operations, it is very logical, right? To me, it's a very simple, easy to understand layout. It's very smooth, right? The product flows in a particular direction, right? Products are not going to move up and down. Products are going to move only in this direction. Products are going to move only in this direction. Product doesn't start from store and then goes to drilling machine, and then comes to grinding machine, and then comes to lathe machine, then comes. Doesn't happen. It's a very smooth flow from in this case from left of the slide to the right of the slide. So very smooth flow. To me, product layout is very logical, very simple, very smooth, even to explain, right? Secondly, since the work from one machine directly feeds into the next machine, usually the work in process inventory is much lesser, right? So what is WIP? What is WIP? Let me give you an example of WIP. Once again, let me quote a non-manufacturing example. So let us say that you go visit a doctor in a healthcare facility. Now what happens? I can see 3 operations there. So first is your registration. You go and register yourself. That's when they ask you for your details, and you are given an ID, right? A unique ID, so that the healthcare facility can identify you the next time you go there. Probably they take the fees upfront, right? This is what happens in the registration. And probably then they take you to the vitals, right? What is that station? What is that workstation? That's when your vitals are taken. Your BP, your temperature, and all those things. Your weight before you visit the doctor. All those are recorded on a sheet of paper, so that when the doctor sees you, the doctor can see all these vitals a priori. So and then you go and meet the doctor, right? So three operations, and let us say that they are arranged in a particular sequence. This is the only sequence. It is not going to happen that you will go meet the doctor and then go see the check the vitals and then the registration. That doesn't happen. In a typical healthcare facility now, this is the sequence of operation. You go first register, Get your vitals done, go meet the doctor. That's the sequence, right? So the sequence is not going to change. Now, what do I mean by this bullet point here? Right, this bullet point second. Now let us say that registration takes 10 minutes and vitals take 20 minutes. Okay, vitals take 20 minutes. Or let us say, I want to explain something else. This takes 12 minutes, right? And this takes 30 minutes. Now, since registration directly feeds into vitals and vitals directly feed into doctors, right? Once the product layout is optimized, there are not going to be too many people waiting here. There aren't going to be too many people waiting here. So, in the sense, if you really want to talk technical, we can say that you won't see too many queues forming in front of these stations. But for that to happen, the product layout has to be optimized, right? So, but in a typical optimized product layout, generally the work in process inventory is much lesser. Total production time is shorter precisely because the waiting time is lesser, right? The waiting time is lesser. And since the machines are located such that the output of one machine goes into the second machine, usually the distances traveled by the workpiece is much lesser, right? And therefore the material handling is reduced. So going back to your hospital example, so since the registration counter, the vitals counter and the doctor's appointment room, they are located next to each other, there is not going to be too much of travel for the patient, right? So the material handling or the distance traveled is going to be much less. Now, what I can do is, since the sequence of operations are decided, drilling, milling, right, lathe machine, since that operation is decided, I can then say that I can have a trained person operating lathe on a lathe machine. I can have a milling machine expert operating milling machine, and therefore training is very simple. Training is very short, simple, inexpensive exercise. They know what product are they processing, right? Go back. They know. So if this person is sitting here, the person already knows how to operate milling machine, and the person knows that they are going to process only one type of product, because only one type of product flows on this assembly line. If the product type is different, they would follow a different assembly line. Right, every product has their own assembly line because every product has their own sequence of operations. Right. So this milling machine operator knows that they are going to process only one type of product. So they become expert very quickly, and therefore the training requirements are actually much lesser in a product layout. Further advantage of product layout, very simple production planning and control. Very simple because the layout itself is quite simple. And lastly, the space required, right? The space required for work in transit, temporary storage, the space required is much lesser. Because the temporary storage requirements are lesser, because there is no transit, right? There is no transit. Directly the output of one machine feeds into the second machine. So there is no transit, so to say, right? So that space between the two machines are quite short. If you really want to get a feel of assembly line, what I will do is at the end of this video, I will put up some publicly available YouTube videos for you to watch an assembly line, for me to explain that in a video better, right? Those videos are not created by me. Those are publicly available videos on YouTube, and I will share a couple of good examples of how the assembly line operates for you. Okay. Advantages done, right? Obviously, since there are so many advantages, every layout has some disadvantages. So product layout is no different. So what are the different disadvantages of product layout? The problem is, if one machine breaks down, the entire line stops. Right? Go back. Now in this assembly line, let us say the milling machine breaks down. That's it. No product can be processed on that line. You can continue to have this milling machine operational, but this milling machine is used in this assembly line. So this milling machine is not available for this product. This milling machine is available only for processing this product, and therefore this line has to stop. If this milling machine breaks down, this line has to stop. One of the biggest disadvantages. A single breakdown in the line stops the entire line. Okay. Secondly, since the layout is determined by the product, any change in the product design, we will have to make a new layout, right? This particular layout will correspond to one particular sequence of operations. If you change the sequence of operations, then the layout has to also change. The layout has to be newly built. Okay, obviously. Thirdly, the pace of the production is governed by the slowest machine, right? Go back to that example. Which example I am going to talk about now? This example. Now let us say that this guy vitals take 20 minutes. Now the registration takes only 10 minutes. Doctors are going to talk to you only for 13 minutes, but the vitals take 20 minutes. So the rate at which the products, in this case the patients, the rate at which the patients can be processed in this healthcare system is governed by the slowest workstation, which is the station where your vitals are taken. Okay, because any efforts you put saying that I will hire the best doctor, why are you even worried about it? Doctors are anyway finishing their consulting in 13 minutes. If you really want to invest, you should invest in having better nurses who don't take 20 minutes for checking the vitals, right? So the pace of your layout is governed by the pace of your production is governed by the slowest machine. This slowest machine is usually called the bottleneck machine. Supervision is general, not very specific, because what are you specializing? Usually comparatively high investment is required because identical machines may be distributed along the line. What do I mean by that? Okay. So here let us say that one product has to be processed on a milling machine twice. Okay. So let me erase this now. And let me say that this is a product requires this sequence of operation. A lathe, a milling machine, a drilling machine, a saw, a milling machine, and a paint shop, a painting job. Okay. If this is the sequence of operation, your layout is dictated by the sequence of operation. You are going to require two milling machine in this layout, once here and once here. You cannot simply say I will buy one single milling machine and be done. Cannot happen, because your layout is governed purely by your sequence of operations. Sequence of operation requires milling operations twice, therefore you will have to invest in two milling machines, because in a product layout the flow of the product is in one direction. The flow is in the direction of sequence of events, sequence of operation. Lathe first, then milling machine, then drilling machine, then sewing machine. This is the direction. Okay, this is the direction. Since this is the direction, when you finish this saw or the sewing machine, you need the milling machine. You cannot say I will finish this milling machine here and then come back to the paint shop. Can't happen, because it will break the flow. It will break the flow, and product layout is all about flow. So the investment in product layout is going to be higher purely because you may have to invest in the same identical machine multiple times, because it is required multiple times in the sequence of operations. Okay, I hope these disadvantages are clear to you now. I hope the product layout is clear to you now. What is product layout? Product layout is arrangement of facilities based on the sequence of operations.